Okay, students. Okay. So let us see the state equivalence theorem. Okay, if I want to call the states SA and SB are equivalent states, then their next state should be equivalent and their output should be same. Then only I can call the states SA and SB as equivalent states. Okay, so that is when that is what is called state equivalence theorem for the states SA and SB. Using this equivalence theorem, keeping that in the mind, we are going to see how we can simplify the completely specified state machines with the help of partition technique. So to apply partition technique, we have clear-cut steps that what we have to follow and using partition technique. Let us see, students, this is a completely specified state machine. In completely specified state machine, we'll have all the present states which are available. What are the next states and outputs we will have for that completely specified state machine for a possible input combinations like x is equal to 0, x is equal to 1 for all the present states which are available. Okay, then students, after knowing and one more important thing that you have to remember is, if you want to apply partition technique for simplifying the state machine, it should be completely specified. Each and every information regarding the present state for the combination of input should be available in the state machine. Like if I have state A, by applying an input 0, what is your next state? What is your output? For the state A, by applying an input 1, what is your next state? What is your output? Okay, each and every information should be clearly available in the state machine. Then only it is possible to apply a partition technique on given completely specified state machine, students. Okay, it is not at all possible if some information is not given in the state table. There are some other methods that are available for minimizing the completely incompletely specified state machine minimization for that. Okay, we'll see those concepts in the later classes. For now, if we want to apply partition technique for minimization, it should be a completely specified state machine, students. Students, have you noted down the entire table, state machine? Have you noted down?
Sir.
Yeah, then just this table is completely required for minimization. Okay, if you go into the later parts, you cannot see the presentation. That's why I'm asking you to note it down. Okay, students, let's go here. If you want to have a minimization of this completely specified state machine with the help of a partition technique, we need to identify each and everything, students. We have to make groups from the state table. Let us see, students, what is your step number 1. Students, very simple technique. This is actually, listen to this one and look at the table clearly. Look at the states which are available here, students. State A, state B, state C, D, E, and F are the states that they have given. Then tell me, students, what is the next state and output for your state A when input x is equal to 0 is given?
Next state is, sir, output.
Next state is
zero.
output is 0,
Then
sir.
what is the next state for when I'm giving x is equal to 1 for the state A? Next state is D.
Output is 1,
The
sir.
Output is 1
sir.
here. Okay, like that. Check what are the states, for what present state you have same next state and same output in there. Check your C, students. Check the present state C. When I'm applying input x is equal to 0 for state C, you have next state E here and output 0. Next state B and output 1 in here. Same output you can see here. Output 0, output 0, output 1 and output 1 here. And check, is there any other possibility like that? Check your present state E here. What is your output, students? What is your output here?
0, sir.
0. What is your output here?
1, sir.
1, sir.
So for the states A, C, and E, you have same outputs. You have same outputs. 0, 0, 0, 1, 1, and 1. So you can make the states A, C, and E as a group, students. And likewise, check other possibilities. Check your present state B's output combinations. What are they? What are they, students? 0 and 0 here.
0, 0.
Check your D states. D 0, 0. And check your states F 0.
Yes,
Yeah, 0, 0. So you can make B, D, F as a single group, students. Okay. Now let me take white screen to explain this. Students, in the step one, okay, in step one, I'm taking my groups like this from your state machine, that I'm making A, then C and E as a single group, okay, and I'm making B, D, and what is other state, students?
F, sir.
F.
Yes, sir.
F as a group. Okay, this is your step number one, students. Okay, in step one, after making them as groups, separate groups, students, here I got only two groups having 0, 1 as your outputs, 0, 0 as your outputs. You may have different combination also. 1, 0 as a group. You can make other group also. Here in the given completely specified state machine, I have only two types of groups having 0, 0 as your outputs, 0, 1 as your outputs. You may have some other group also, like 1, 0 as your outputs. Like that, you can have several groups here. But for the given state machine, I have only three states having 0, 0 as your outputs, 0, 1 as your output, students. Okay, so after making groups, what you have to do is check zeroth successor. Okay, zeroth successor of your states A, C, E, students. Okay, check which states are having 0 states. Okay, like this, zeroth successor of the states, given states A, C, E here. Okay, zeroth successor of A state, states A, C. Tell me, students, zeroth successor of A means, check your present state A and tell me what is its next state when 0 is your input. Tell me, what is the
E,
next
sir.
state when
E,
I'm
sir.
giving 0 as input to
E,
your
sir.
states A. So that is your E. Okay, E you are telling, so I'm not noting it down. Then what is the zeroth successor of state C here?
E, sir.
E.
E, sir.
Okay, so
E,
I'm
sir.
writing E. Then what is the zeroth successor of state E?
C,
C,
sir.
sir.
C, sir.
C. So I'm making E, E and C as one group. And tell me, students, what is the zeroth successor of B, D, F?
F, B,
Yeah,
sir.
yeah,
Okay,
B, sir.
so F,
B,
F,
F, B,
and
sir.
B.
B,
Okay,
sir.
I'm noting them. Noted them down. Okay, then tell me, students. Okay, B it is. What is the one successor now, students? Okay, you have to say what is the one successor? One successor of the same things. What is the one successor of the given state, students? ACE only I'm asking. What is the one successor of
D.
ACE? Tell me,
D,
student.
D, F, sir.
D, sir. Sir.
F,
F, sir.
BDF.
B, F,
So what is the yeah?
B, F.
Sir,
Listen,
D,
listen.
B,
D,
F,
F,
sir.
sir.
Okay, okay. So I'm writing D, B, and F. Okay, thank you. Then what is the one successor of this BDF? One
D,
successor.
B, C, sir.
What?
D, B, C,
D,
sir.
B,
D, B,
C,
C,
sir.
sir.
D, B,
D,
and C. Okay, students.
C, sir.
So after writing zeroth successor and one successor, you have to check one thing, students. What is that? Look at here. You wrote what is the zeroth successor of AC. You told that is E, E, and C here. Students, check here whether E, E, and C is there in the same group of these things. Whether E, E, C are there in a single group or in separate groups. Look at here, E is there in this group, E is there in this group, C is there in the same group. So is there any different group, students? E, E, C is there in the same group or in different groups?
Same group.
No, sir.
Same group. Same group.
Same group, sir.
Yeah, same group. So I no need to separate them into separate groups. Okay, I no need to separate A, C into separate groups. Then check zeroth successor of F, F, B here, students. F is there in this group, F is there in this group, and B is there in the same group. So F, F, B is also there in the same group. So there is no partition here also. Now check one successor, students. D, B, F. D is there in this group, B is there in this group, F is there in this group. So DBF also is there in same group, which means that I no need to separate A, C, E into separate groups. Okay. Then check one successor of BDF. What are they? DBC here. D is there in this group. B is there in this group only. What about C, students? What about C? It is
Other group,
available
sir.
in other group. So what you have to do, you are moving into step 2 now, students. After checking 0th successor and 1 successor of the states ACE and BDF, from ACE, when you check 0th successor and 1 successor, both are available in a single group alone. They can be present in any group, but all the things should be in one group only. Once again, check here, students. When I'm checking 0th successor of ACE, I got EEC, E and C are available in the same group, so there is no division here. And when I check 1 successor of ACE, they are D, BF, D, BF are also available in the same group. So I don't want to, I should not have to partition them. So I should make A, C, E, okay, into same group. ACE will not be partitioned. I will be writing ACE as it is. Then check here, students. What about 0th successor of BDF? FFB. So when I check FFB is there in the single group or not, FFB is there in the single group. According to 0th successor, there is no partitioning of BDF. But when I check one successor of BDF are D, B and C, students. Check whether DBC is there in the single group or not. D is available in the second group. B is also available in the second group. When I check this third element, that is C, which is available in the first group, which means that both next states of B, D are in the same group, but the next state of F, that is C, which is available in the separate group. So I have to separate them into separate groups. I have to separate B, D, F into two groups. How? Since B and D, its next states. B's next state is D. D's next state is B. These next states B and D are available in this group alone. So I'm making them as a single group. Since F's next state is C, which is available in the other group. So I'm writing F as separate group. F as separate group. Students, do you understand how I wrote this one?
Repeat, sir.
Look at here. Repeat, yeah. Look at here, students. When I have to write 0th successor and 1 successor of ACE first of all. So 0th successor of ACE is E, E and C. 1 successor of ACE is D, B, F. So I have written them. Then check 0th successor of ACE is in a single group, available in a single group or not. Likewise, check AC is 1 successor is available in a single group or not. That is what you have to check here, students. Okay. So what you have to do here, since when I check 0th successor of ACE is E, E and C are there in a single group. How? E and C all are available in a single group. When I check 1 successor of ACE, that is D, B and F are also available in a single group only. So no need to partition this. We no need to divide the groups ACE here. But when I move to the states, okay, 0th successor of BDF and 1 successor of BDF are like this. When I check their next states are available in the single group or separate groups, F, B are available in a single group. So according to 0th successor of BDF, there is no separation. But when I go to the 1 successor of BDF, D is available in this group. B is also available in the same group. But the next state of F, C is available in other group. BD is available in this group, but C is available in this group, students. So BD will be kept in a single group, F will be kept in other group. Students, do you understand how I have separated this BDF? How I have
Yes, sir.
separated BDF? So BD's next states according to one successor are available in a single group. So I kept BD as it is. But the next state of F is C is available in other group, students. So F is separated here. So we have moving, now we are moving into state 1 to state 2. So in state 2 we have some separation. In state 1 ACE is single group, BDF is single group. But when I'm moving from state 1 to state 2, ACE is same group, but BDF is partitioned like BD into a single group and FS separate.